Bismillahirrahmanirrahim. This is lecture 3 of surveying 2, and today we will discuss about the cross-sectional area, how to find the cross-sectional area from a survey data. So let's see actually what is what is the what is actually cross-sectional survey, cross-sectional area. I'm sorry. Let me. Cross-sectional areas are necessary for measurement of earth volumes in roadway construction or in dam construction. They are profile views of the ground perpendicular to the center line or baseline, indicate ground elevations at points of change in the ground slope. Sections are usually taken at a predetermined intervals, 50 feet or 100 feet along the center line or a baseline. An elevation is taken at the center line and at intervals right and left of the center line, normally 25 feet or 55. Sometimes elevations are taken at points other than the normal interval depending on the terrain, location of changes in the slope of the ground. For instance, uh, I am surveying along this line. This is my center line, and say at this point, at this point, I will take the cross sectional area. How I'm standing maybe on this point, and I will take one level. If my direction is like this, I will take one level around 25 feet on my left and one level at right 25 feet from my sorry. If I'm standing on this point, this the level I have taken is this what we call at on the left, and this the level I've taken on this point is the right. Now, if I look at the cross section, there is this of elevation, and this is a distance from the center line. For example, from center line, 18 feet to the right, I have 126 feet elevation, and then at at 120 further to 29 feet, I have this elevation of 124 feet, and then at 41 feet, I have this elevation at 136 feet. And presuming I have this 126 feet as my benchmark, obviously this is level showing height, and this is the level showing depression. Similarly, if I take the level on 20 feet from my left, I've got 129 and 136 and 75. At 75 feet, I have got elevation of 126 feet. So actually, if you want to differentiate what you have done in the previous lecture and what you are doing in this lecture, it's about taking the area. In the previous lecture, what you were doing, you were taking the planning area like area of the floor. But in this lecture, in this technique, you are taking the area of like area in front of you. That is, if you can say this is the area along the wall, area just in front of you. Take first take this example. There is a road along this line, and we 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 are taking elevation at different point along the center line. So this is my center line, right? And this is the whole width of my road section, right? We call this as fill because the surrounding ground level is below my pavement level. But if I go further, you can see that this road level is below this ground level. So you can imagine this is a section when are you going through like a underpass where you are just approaching the underpass. At this point you have approached the underpass and now you are in the underpass. So this area in which your surrounding ground level, or in case you can take it like this way, if this is a tunnel, then this area is called the cut area. And if you have a mountain and if you have higher elevation, normally in roads we do have, then this is what we call a fill section. And between cut and fill, between this, there's a transition always from we go gradually from fill to cut section or cut to fill section. So what I have done, if I look at this diagram, you see if I take at this point, elevation at this point, at center line and both at the corners, I have had higher elevations. But if I move at this point, on the left side, I have a zero elevation, and on the right side, I have a higher elevation. So this also, this point at A, this I will call as a fill section. Now, point B is different. On one side, you have a higher elevation, and on the other side, you have a lower elevation. So we'll say at 1140, station 1140, I mean 1140 feet, the elevation, this station at B is called part cut, part fill, right? Because half of this width has got lower elevation and half of this got higher elevation, as you can see. Now, if I go at point C, then this is a fully cut section in which the elevation is at the lower side and so on and so forth. At this point, you see, actually see, the other thing is that the for cut, the bottom width is higher. The, for cut, the bottom width is lower and the top width is higher. But for full section, the top width is less as compared to the bottom width. So again, if this is my ground level and if my structure, pavement structure is at higher level, we call this a fill section. If my structure like this is at lower level, below my ground, that we call a cut section. By cut section, I mean that all this material below this ground level has to be removed to make a structure. And for fill section, I mean that all this structure has to be built over this grounds. And for cut and fill, you have to fill something and you have to cut something. For at this point, on the left, you have to fill, and here you have to cut. So we call this cut and fill section. So how you calculate the area of these earthwork sections? There is a simple template given to you and you have to understand this template. So whenever is a problem is given to you, whenever the surveyor gives you this type of level, you have to understand which formula you apply, or in other words, is it a level section? Is it a 3-level section? Is it a 5-level section? And it is the area irregular section, or is it the transition section, or it is a side hill section? Now, how you recognize? You see, in the level section, there is only one level that is given to you. That is the center height in C. And then there is a side slope. And this, we can say, this is a side slope, S is to 1. Or you can say 1 is to S, whatever you say. And then this is the width at the bottom. I call this is level section because there's only one level, that is one height is taken. That's why this we called as a level section or one level section. To calculate the area of this figure, I mean this trapezoid, and obviously this is a cut section. Why? Because the ground is above and this, and again another point is that the width at the top is more than the width at the bottom. So this is a cut, and this is a one level section, and this is a trapezoid. Now, this is a three level section. Why? Now you can see I've taken three heights. One at height center, one height at the right of my cross section, what we call HR. This is the height at the right. Height at the center is always denoted by C, and then HL, height at the left. Now, there is a way of writing this point. Now, this, whenever I take level, so what I do, I say F means this is a fill section, and 5.2 means the height, the value of C is 5.2. Then, if I go to the left or right of this figure, I can tell you that this F means again the height is above the ground. This is a fill section. F 5.15, 5.1 feet is the value of HR, and this 20.1 is means the distance from center point to the right of the section. Now, this, if I go on the left side, so this is the distance L from the left side, and this HL is the height, and this is the distance. So even if this is not given to you, and if you have been given this thing, F6.0, 21, F5.2, F5.1, 20, first of all, you will say this is a three level section, and you will apply this formula. And for three level section, I means three height is given to you, 6, 5.2, and 5.1. And obviously, you don't have, don't put this underline at this point, because this denote this is the center point. And if you have a underline, then it means it is not center, it is away from the center, obviously to the right, and this denote the distance from center line to the left. So this is a three level section. In order to calculate the three level section area, you have to use this formula, DL, that is 21 feet, DR, that is 20.1 feet, C, the height, this is 5.2 divided by 2. Similarly, B is the width of the finished structure, or what we call the formation width. HL, here HL is 6.0, HR is 5.1. So this is what we call the three level section. Now, based on this concept, now you know this is a five level section. Why? 1, 2, 3, 4, 5. Okay. Now, C means they are all in cut again. You see, the width at the bottom is less than the width at the top. And now This is C, and that's why it's 5.8 feet. This this is FR, fill at the height at the right section, and this is 15 feet, and height at the left section along 50 feet on the left. This is 15 feet. The height is 6.7 and 6.2. Again, all C denotes cut. And then this is 21 feet and 22 point. Incidentally, you must understand, though we are calculating the area using 5 level section, again, we are not interested in these values. So, though it is given, you are not going to use, okay, no, we are going to use, but there is a technique for that. For instance, you will use DL, and DL is 22.1, DR you use 21. And the height you will use not at this point, but at this point, just above the straight section. So in other words, this slope has been ignored. The height at this slope is ignored. So for us, while calculating, this 15 is redundant, so is 6.0 and 7.1. So we'll take 6.7 and 22.1 and 6.2 and 21. And again, the width is given to you, and you can find the area. Now, for this, I will explain you how you calculate the areas for cut, fill, and transition in the problem that I am going to explain to you. Now, how you going to calculate the area of this? You must be wondering whether this is a 5-level section, whether it is a 3-level section. Actually, what is this actually? This is a bit confusing. So actually, this is what we call a multiple section. And here you will use a simple technique of what? Double definition of area using coordinate method. How? I'll explain to you. Now, what you do? You divide this figure into different areas. For example, you see O, D, C, C dash. So this is one figure, and this is a trapezoid, right? And this trapezoid has a width of 20 feet, one height 18, and the other height is 15.8. Now, this is triangle CL, C dash. Here, so this is one area, this is second area, now this is third area. This is 10.1 trapezoid having a 12 feet and different heights, and then there is a triangle. This is 10.1 having the base, and this is the height. So if you calculate ODCC dash, this is 18 plus 15.8. 18 plus 15.8 divided by 2 multiplied by 20. This is the area. C dash CL, C dash CL, this is 15.8, and the height is 12.5. So 15.8 multiplied by 13.8 divided by 2. High 13.8, because you see this overall is 20, and this is 33.8. So actually we are knowing this area, once you know this area, we separate this area from this area. What is HLC dash? HLC dash is this area HLC. Now HLC dash is minus 5. Why minus 5? 20 minus 15 is minus 5. Then the height, again this height is 12.5 divided by 2. So this is minus 32. Then you go to the right hand side, ODE dash 10.1 plus 18 multiplied by 12 divided by 2. And then we'll go with this thing again. This is what? This is 12. So 33.3 minus 12 is what? 21.3. This is height and divided by 2. And again, this E dash RG 3, 12.2 and 2. 3, because 15 minus 12 is 3. 12.2 by 2 is the height, and then multiply. So this I feel is one way. Another way is also a very simple way by using coordinate method. Now, what you do? To find the coordinates of each of these points, like you do in the first example, I was trying to explain you the area of the plane. Now, you have to calculate the coordinates of all these points. Remember, this is a coordinate system. Whenever you start with one point, you will finish at this point. So, what you do? This is my 0, this is origin. So this is my origin, so its coordinate will be 0, 0. Next point is H. This. So here the coordinates, X coordinate is minus 15 and Y coordinate is what? 0. So you will calculate you will take the coordinate of L. Now the coordinate of L is minus 33.8 and height Y coordinate is 12.5. So the coordinate of L will be minus 33.8. Now why say minus? Because it is on the left side. I say plus when it is on the right side. So the coordinate of L will be minus 33.8, minus 33.8 and plus 12.5. The coordinate of C. So this is 20, this is minus 20, and the Y coordinates is 15.8. When I come to point D, now X is 0 here and Y is 18. So the coordinate of D will be 0, 18. I move on to this point E. Now the X coordinate is plus 12 and Y coordinate is 10.1. And if I want to calculate coordinate of R, because this is the figure, Y coordinates will be L, C, D, E, R, G, O, and H. Okay. So now if I go to R, the X coordinate is 33.3, Y coordinate is 12.2. If I come at the bottom now, Y coordinates become 0, X coordinate becomes plus 15, and consequently, since I've started this loop from 0, again I will come at O and we will have 0, 0. So let's see. This is how you see. First coordinate 0, 0, minus 15, 0, minus 33.8, 12.5, minus 20, 15.8, 0, 18, 12, 12.1, 33.3, 12.2, 15, 0, 0, 0, and then you know what to do. Just cross multiply 0 into 0, minus 15 into 12.5, minus 33 into 15.1, like you did in this previous class. So this will be a plus column, this will be minus column, add them, divide it by 2, and you will know the area of this very complex section in a very easy way. Now this is when you don't have a simple geometric figure like this. If you have simple geometric figure, do it. Use these formulas only. Those of you wondering whether they have to learn this formula, my answer is yes. You have to learn this formula. You have to learn it. Now, if I need to ask the calculate the volumes, of cross-sectional areas, actually, as I said, we are always interested in knowing the volume. How we are going to calculate the volume? Volume is calculated by, a volume is nothing but area into length. So if I have been given this area, now here the area is already given, and all I need to know is the length. So I have at station 10, I means 1000 feet, and station 1100 feet. So I will calculate a volume between these two areas. Simple. What I do will add this, divide by 2, multiply by 100. Right? So this you will get the area. Now at this, between 11 and 1121, this is a 21 feet. So this is my length. I will add 421 and 68 divided by 2, because now I will calculate area between these 2 points. 421 and 68 divided by 2, multiply by 21, because this is the length. Now for this 1121 and 34, and I have to calculate both areas, and then both area and cut and fill section. So between this and this, the difference is, what you do, 0 multiply by plus 34, that becomes 17, and then you multiply by 1140 minus 21. So this becomes what? This becomes 19. Similarly, for fill, 68 plus 31 divided by 2, multiply by this, and you will get 29. Similarly, 34 and 144, add them, divided by 2, and multiply the difference between these two values. The length is 24. 1164 minus 1140. So this is how you calculate the areas. And since the fill areas is always, whatever you get out the thing, there is an expansion factor, say 25%. It's very simple. If you have a 1 meter by 1 meter by 1 meter depth, obviously the volume will be 1 meter cube, but that is a cut volume. Now, if you want to fill it, then you have to need an extra material. Why? Because when you were excavating, the material got compacted. In other words, there was some water in it. That water has absorbed, and while absorbing, it consumed more soil, more earthwork. So that's why if you cut out 2614, you have to fill it. For filling the volume of 2614, you will not need a volume of 2614, but you will need this. You will not need 2614, but you will need 25% or 10% extra. Another point you must be wondering that if I add 992 and 421, divide 2, multiply by 100, you will not be getting 2614. Why? Because this is fit, fit, and this is yard. So what I have done is that after adding this 2 and taking average and multiplying this, I have divided by 27. What is 27? 1 yard is 3 feet. So 1 cubic yard will be 27. My area was feet cube and I've converted in yard cube. That's why. So you can always understand this 34 and 0, this becomes 34. 17 multiplied by 19 is something else, not 12. But since I'm changing the unit, all these values have been divided by 27, right? To convert yard cube into foot cube. Now, if you don't want to convert like this, what you can do, what could have done, is to take this only foot cube, and at the end, after cumulative, you can always divide it by 27. It won't make any difference. Okay. So I think this you have understood. And then this full volume. So actually, the difference, so this will be a fill volume, cut volume, and the fill volume, the actual fill volume is this, but the material that is required is to be this. So that's why when we say cumulative fill, so we'll add these two values. So for me, this is first point 0. So 0 minus 3.3268, this become minus 3268. Then minus 3268 minus, I'm taking the difference between the volumes, right? So minus 3268 minus 238 becomes minus 3506. Minus 3506 minus of minus 37, minus 37 becomes 3531, so on. And because now, actually what's happening here is I'm taking the difference, right? So this is how you calculate the values. Now here minus 3916 plus 2967. This now what you're doing, you are doing the cumulative volume. I'm sorry. I'm very sorry about this mishap. What I'm trying to say is that what you do, you are taking the cumulative volumes. Cumulative volume means cut and fill volumes, right? So at this point, we'll say this as 0. Now I will take 0 and minus 3268. This becomes minus 3268. And then minus 3268 minus 238 becomes minus 3506. Here, this is a fill volume. Now, minus 3506 minus 37 plus 12, this becomes minus 351 because there is a cut volume as well. Then minus 3531 minus 17 plus 79, this becomes minus 3469. Now minus 3469 plus 553 becomes minus 3916, and minus 31916 plus 2967 becomes plus 51. right? So I stop here, uh, and then we will continue in lecture 4 with again this lectures of calculating volume of the cross-sectional area. I hope you have understood, and obviously in the class we will solve some other problems so that your concept got clear. Thank you very much, and this ends my lecture number 3.